day. So now we're going to cover the last gas law, which is pressure versus moles. It works the same way as all the others. So we have a relationship between pressure and number of moles that is a direct relationship or proportional. P over N is always constant, which means that we can say P1 over N1 is equal to P2 over N2. And as usual, if I increase the pressure by a certain factor, that has to be related to the number of moles increasing by the same factor. Normally we're going to look at it the other way. So we're going to say, for example, if we double the number of moles, well, the pressure should probably increase by a factor of 2 as well. So if we look at the graph, because we have a direct relationship, a proportional relationship, we get a straight line. Again, it ends up at the origin. Why? Because if there are no moles of matter, if there is no matter, there are no collisions, and therefore there cannot be pressure, since we know that pressure is exerted by collisions from the gas, between the gas particles and the walls of a container, for example. So no matter, no collisions, no pressure. So we have the line ending up at or starting at the origin of the graph. So if we look at the relationship from the kinetic theory point of view, so it says if the number of particles increases, the number of collisions between them will also increase, and that increases the pressure, right? A direct application of this, actually it's kind of a reverse application, would be when somebody dives with a gas tank. So for example, I have my gas tank. Sorry. So I have my gas tank. I'm sorry, I'm not very good at drawing. And on the gas tank, I have a dial. So if the gas tank is full of gas, well, the particles are moving around, right? They're all inside the tank. It's compressed. So the gas is compressed and we have a lot of collisions. So more collisions mean a very high pressure, and it's going to be indicated here on the dial. Now, during your dive, you're breathing some gas. So during the dive, because the particles of gas are disappearing, you're breathing them in. Well, there are less collisions, right? Because there's less gas, and therefore the dial will start showing a different reading. The pressure inside is going down because you're sucking out the gas and you're decreasing the number of collisions, and therefore the pressure. So at a certain point, when the pressure shows, when it's too low, you know it's time to get out of the water. So that's basically the relationship between number of moles and pressure, but based on the kinetic theory. Moving on to a mathematical example, so we have one in store for you. We have a car tire that is suitably inflated, contains approximately 5 mole of air at a pressure of 220 kilopascal. How many moles of air remain inside the tire when it has partially deflated and the pressure indicated on a manometer is 185 kilopascal? So what we're going to do here, so we're going to use, of course, P1 over N1 is equal to P2 over N2. So if we replace, P1 is 220 kilopascal, N1 is 5.0 mole, and on the other side we have 185 kilopascal, and we're looking for the number of moles that it corresponds to. So we're going to cross multiply to find the value of N, and the value of N is, value of N is 4.2 mole. So that's it for this gas law. Stay tuned for the next episode.